When we create service classes inside the client class, we create a tight couple. Let's add some new functionality. The player's health should now regenerate if it's lower than 25%. Some enemies might also have this feature. Also, a single armor class is not enough, and we want to add additional armor types, like chain armor, plate armor, hero armor, and so forth. To make those changes, we create Regenerating Health class derived from health, and create all the armor classes that we want derived from the armor class, which becomes abstract. Now here comes the problems. First of all, in order to use the new Regenerating Health, we must update the player class. If those classes are used somewhere else, for example for enemies, the number of places we need to update is increasing. Secondly, if we create a new armor type object, for example a hero armor, inside the inventory class, how do we make a player to have a hero armor while enemies have plate armor? By the other hand, if we inject the new classes into the player and inventory class constructors, no additional changes are required for the player class or any other clients. You might come up with another solution: use interfaces instead of inheritance. Now any class that implements the interface can be injected. Avoiding tight coupling is the main idea of the programming principle called inversion of control, and dependency injection pattern allows us to follow this principle. Another example of dependency injection usage comes from the unit testing perspective. Let's teach our player to take damage. Some damage is going to be reduced by the equipped armor, and the armor should become damaged on taking damage, and we want to test that. The armor state is saved in the public property. The problem is, we cannot get it from the player class, since the inventory is stored in the private field, and the armor is saved in the private field in the inventory. Dependency injection solves the issue without adding any new code. We create an armor object, pass it to the inventory, then pass the inventory to the player. After player takes a hit, we use the saved reference to check the armor state. In conclusion, dependency injection allows us to create a loosely coupled architecture which has a lot of advantages. Here is only a few of them. Extendability. A new functionality can be added without rewriting the old code. Rewriting existing code is one of the easiest ways to break something that worked well. Parallel development. One developer can work, for example, on the extended inventory class, while another is working with health class. Without dependency injection, both of them might update the player class, which can lead to a great mess. Easy to unit test. As we saw earlier, dependency injection allows you to test functionalities that might be inaccessible otherwise.